Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Welcome to another episode of Lost in Science, and as usual, every week we bring you the best science that we can find in the whole world and beyond, occasionally. Because, we don't like to stop at the boundaries of the atmosphere or of the... even sometimes we've been known to go beyond this universe. We'll stop at nothing. That's the dedication that we will show for you. Anyway, who knows how far we will travel tonight. With me, as always, are Claire and Stu. Claire and Stu, how are you?
Very well, thanks, Chris.
Yes, well, Chris, how are you?
Yeah, great. And what have you got for us this week, Claire?
Well, this week we have a guest on Lost in Science, Dr Cathie Page, who is a researcher and a postdoctoral researcher with the Australian Institute for Marine Science. And maybe you've seen some of the news reports that some very clever scientists have been working incredibly hard and have, in a laboratory, managed to get corals to spawn out of season, which is a big feat because this doesn't happen normally. Corals have two times that they spawn per year, and it's a mixture of sort of like environmental factors and the moon and the temperature. You have to get everything sort of aligned and right for corals to spawn, and you just sort of be able to generate little baby corals. But they've just been able to do it in the lab in Townsville, so I'm going to catch up with Dr. Cathie Page and hear all about it.
Wow, that's amazing. Huge potential, I guess, for like conservation, I suppose, is one practical application. But also 100%. Understanding how spawning works, being able to do that shows a great understanding of the mechanisms, I suppose.
Yeah. And it can't come soon enough in terms of management and help for incredibly vulnerable coral populations on the Great Barrier Reef. So it's going to be fascinating to talk to Cathie all about that.
Well, that coral story is going to be hard to top, but reef it to Stu to have a go.
Very good.
Stu.
Well, yeah, I don't know how to follow that seamless segue there, but we talk about science from a lot of different angles on the show, and one of the things that is fascinating is how some bits of science get picked up by people in society and in culture, and they run with it. They grab onto it, they run with it, and they define their whole life around bits of science, which, can often turn out to be misunderstandings of what the science means, or just a complete misinterpretation, or in some cases, the science has been misrepresented from day one, and people have just not understood what it was actually saying in the first place. I've been reading a lot lately about the origin of the concept of the alpha male. You probably have heard of people use this term, the alpha male, and it stretches back to, apparently, to wildlife studies of wolf packs. The wolf packs have the alpha male that leads the wolf pack, and there's all these sort of rigid hierarchical structures within the wolf pack. And people have adopted that and said, well, I'm an alpha male of a human kind of thing, and they've tried to paste this concept onto human society rather than onto wolf hierarchies. But look, let's just cut to the chase and say it's wrong. It's basically just wrong. People think it's based on science. There is a long history of science into animal behaviour and all these sorts of things. But in the end, it's a complete misunderstanding of wolves and their hierarchy and their social structure, and it's been pasted onto human society, which is actually quite unlike wolf society anyway. So I'm going to talk about that, and I'm going to talk about what the actual research is, what it has shown, and why people who go around saying they're an alpha male probably should just stop saying it, I think would be the simple solution.
Great. Well, I'm really looking forward to that one. We had two kind of moon-related stories, I guess, in some ways. Wolves and coral? No? Anyway, look, stay tuned for this amazing show, and if you're a fan of Jordan Peterson, please don't call us.
So you may have heard of coral spawning season, that time of year where all the environmental elements align and corals spawn en masse. It really does sound like quite a sight. But this event has been a bit of a mystery, only happening twice yearly, limiting the science, research and conservation that can be done on the Great Barrier Reef and in coral reefs across the world. That is until now. And with us this week, we have marine biologist from the Australian Institute of Marine Science, Dr Cathie Page, to talk to us about a breakthrough that's just happened and what this means for conservation and future research. Cathie, welcome to Lost in Science.
Hi, Claire. Great to talk to you.
Now, Cathie, tell us, what is the normal natural process of coral spawning on the Great Barrier Reef? What does it look like?
So most corals produce their eggs and sperm that they release into the water column over about an 8-month period. And they use cues from the environment, so temperature, increasing temperature later in the year, but also phases in the moon, from full moon to a small moon, and also changes from day to night to really tell them when they should release those eggs after that 8-month period. And so what we've been doing here at AIMS is, I suppose, manipulating corals and kind of tricking them really by providing those cues at different times to cue them to spawn at a different time of year.
Right. So this is cues that happen over an 8-month period.
Yeah. So they are, the corals are quite simple animals really, but they can see and they can feel. And so they can perceive the environment, and they use lots of those different cues to kind of say, okay, well, I should be making my eggs now. And okay, the temperatures are getting warmer, I should be producing sperm. And now, okay, I'm really ready. Let's go, let's spawn. And incredibly, so many species, use these same cues to spawn at the same time of the year, but also at particular times of night. We find that individual corals of the same species will spawn at set times in the evening. So some of the massive corals will be spawning at 6 p.m. as the sun goes down, but then there's other groups of species that might spawn much later at, say, 10 p.m. So they all have their kind of little windows that they prefer to spawn in.
Right. So the great sort of spawning event is sort of a bit of a fallacy.
Oh, no, certainly there is a very big focus in terms of the spawning happening in a very brief window, but it is a little bit more complex than just one night of the year on the Great Barrier Reef. It is spread out over a couple of, a number of days and, through the evening.
So from a research point of view and as a marine biologist, can you talk us through, I guess, what are the challenges in having this event take place over only a couple of days in the year and sort of, having these environmental, factors influence it?
So my research is focused on the very early life stages of corals, so very young corals that have been settled out. And so we're really focused on this very limited period in the year, November to December, in which we can do this work. So there's a lot of pressure on the facilities here at the Australian Institute of Marine Science. A lot of people want to work on these early stages. So we're all really cramming our work into that narrow window. And having potentially multiple spawning periods across a year means that we can spread out our work across the year. That's fantastic. So we can also take the learnings from one spawning very quickly into the next. So typically if corals spawn only once a year, then it's another year until we get to try a different technique or a different culturing method, or even do a separate experiment. And so having the opportunity to spawn corals at different times of the year means that we can take the learnings from one spawning event to another quite quickly. So we can really fast track our increased knowledge of coral biology, particularly of those early life stages of corals.
Sounds incredibly important, especially with all the stresses, pollution and climate change and all the other stresses that are impacting on the reef at the moment. I was wondering, Cathie, can you talk us through a bit more about the logistics of how AIMS, the Australian Institute of Marine Science, and your colleagues, came to be able to have this breakthrough to be able to develop the out-of-season coral spawn? How did it all happen?
So this is really the fruit of years of work by our CSIM technicians, our aquaculture technicians. So they've been working for years holding these corals in the National Sea Simulator. These corals were actually bred in the CSIM, so they've never experienced the reef, which is quite incredible. So they've never been on the reef. They've always been and lived in aquaria. And so over that period, as they've gotten bigger and towards a size at which they should be reproducing, so corals start off very small, and they don't start to be reproductive until they're about 3 or 4 years of age. So these corals have been in CSIM for quite some time. And over the last couple of years, our CSIM technicians have been shifting those environmental cues to indicate that the temperatures are warming at a different time of the year and the moon phases are changing at a different time of the year. So this is really a very long-term experiment, and a lot of work's gone into getting this result.
Have they been focused on a particular number of species, or is the CSIM, which I love the name, is the CSIM sort of reflective of what the coral reef looks like at the moment?
We have a number of coral species in the CSIM, and this spawning event recently has included 6 different coral species, so a range of species. And also really interestingly, CSIM has been able to trick these corals to spawn at a different time of year by providing those environmental cues that trigger spawning out of season. But they've also managed to also bring the spawning forward in the day, approximately 4 hours. So currently, corals typically spawn, after sunset. Mm-hmm. And that means that we do a lot of work at night. We have very long nights during this very narrow period of time. So if we're also able to shift our work forward, that's fantastic for safety. It also means that we get to go home, a little bit earlier in the evening, which is fantastic.
Happy scientists, happy research.
But isn't it amazing? These corals have never seen the reef. They've lived their entire life from when they were born in the National Sea Simulator, and they still know what time their species spawns on the reef. It's amazing.
Wow. Continually surprising us, no doubt.
They're much smarter than we think. It's quite incredible the more we learn, and having access to multiple spawning opportunities within a year will really, really ramp up our knowledge of those early life stages of corals, but also coral spawning.
Has this sort of breakthrough happened anywhere else in the world? This is the first time in Australia, I believe.
Yeah, this is certainly the first time in Australia. There are a number of other research groups around the world that are working on this, so particularly the UK. But we do believe that this is the first time that the spawning timing of corals that were actually born in captivity has been shifted. So previous work has focused on bringing adult colonies from the reef indoors into aquaria and then shifting their spawning timing. Mm-hmm. So we do believe that this is a first, a worldwide first.
So now we have this process, we have these corals, we understand more about, the environmental factors and how to shift their spawning events. From your perspective, what are the big sort of implications for further research about the Great Barrier Reef?
So my work looks at where corals, very young corals, survive best in the environment. So our research is reliant on the outputs of these spawning events. So we collect the spawn, we settle them onto artificial surfaces, and then we deploy them to reefs across environmental gradients to look at the effect of those environmental factors. And so having access to potential multiple spawning events in a year is fantastic. We can really ramp up the work that we do in this area. I could also say, so our National Sea Simulator is undergoing an expansion, and so we're really also excited about this result because it means that we can really make better use of an enlarged facility. So that's a fantastic outcome.
Do those CSIM corals, if they're then transplanted into the wild, will they then switch their spawning times to, a wild spawn time?
So at the moment, the corals that have just recently spawned, the ones that we've just tricked to spawn at a different time of year, they've actually been utilised in experiments within the CSIM, so they won't be outplanted to the reef this year. But certainly in future years, there would be, plans to outplant them to the reef. And I would expect that those corals would experience the environmental cues on the reef and then spawn at the same time as their species spawns on the reef. So I think given exposure back to the natural cues, they would continue to spawn in that natural time frame.
Fascinating. So, Cathie, it sounds like, this is an incredible breakthrough, and there are a lot of ideas for, different ways to apply, this sort of new laboratory system and, increased research. What are the next steps that you're going to be going through?
Yeah, good question. We've got a couple of next steps. The first is to look at a wider range of species. So to see whether this system can trick those corals into spawning at a different time of year. So then our species of preference, can we get them to spawn when we'd like them to? And then the other step would be to bring in colonies from the reef and see how long it will take to actually shift them. So typically for a spawning event here at CSIM, we collect coral colonies from the reef that contain mature eggs and are ready to spawn. And we bring them in just ahead of spawning. But if we can bring those colonies in and then delay the spawning of some of those colonies, then potentially, we can spread our work out over a number of months rather than trying to cram it into 1 month. So that's certainly an exciting next step.
Absolutely. Well, Cathie, thank you so much for your time today. It sounds like an incredibly busy time for you in Townsville at the CSIM. Best of luck for the research, the next steps, and congratulations to all the scientists, researchers, and aquaculture technicians from the Australian Institute of Marine Science who've worked on such groundbreaking research and breakthroughs for our beloved coral reef.
Thanks, Claire. Great to chat.
I think we're lost.
We're not lost.
Not even any short-range radio signals yet?
Except for a single, very powerful radio emission.
Of course, a transmitter of that sort isn't exactly standard equipment.
Science and technology must be absolutely mind-boggling.
Of course, that's mostly on the theoretical side.
Well, so far.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
If someone told you they were an alpha, what would you think they were trying to say about themselves?
Ooh, head of the pack.
Yeah. That's cutting straight to it.
Bit of a silverback or something.
Yeah, are we saying what they're trying to say about themselves or what they're actually saying in the subtext?
What they're trying to say about themselves. Okay. What you interpret it as is entirely up to you. But, it basically means they think they're the top dog, right? And the term alpha male, or often just alpha, is thrown around a lot in certain circles of, seems to be particularly men, along with terms like beta as well, to distinguish other men who are beneath them in what they see as a natural hierarchy based on the laws of nature. But in reality, literally back on planet Earth, the laws of nature are not so clearly defined, and they vary from species to species based on very complex and highly changeable political systems within species of animals. But the concept of the alpha male is usually claimed to be based on real, actual, well-established science, which is supposedly from looking at the way wolf packs behave and the hierarchies created within them. And this goes back as far as research from the 1940s, at least that far anyway. And it's now become sort of widespread accepted knowledge through the latter half of the 20th century, persisting now into the 21st century. But to put it bluntly, it's probably just a load of crap. Wolf packs don't really work that way at all. And the real science is a lot more familiar and even makes probably a lot more logical sense. And it will certainly make sense when I explain a little bit more about how wolf packs do interact. So we're probably all aware of the concept that wolf packs are set up according to a strict rank system. The oldest, toughest wolf is the boss, and his female partner is the girl boss. The alpha male and female, they're the leaders of the wolf pack. And the other wolves follow their lead because those leaders have shown themselves through fighting and survival to be the best candidates for the job. And in order to become the alpha, a wolf has to challenge the alpha, and then they become the alpha, and it's all this big meritocracy of who's the toughest wolf in the pack. And the research this is allegedly based on comes from observation not of wild packs of wolves, but actually this is based on research of wolves in captivity. And the most early published research that this is probably related to is research on wolves in the Basel Zoo in Switzerland, which was research conducted by Rudolf Schenkel in 1947. Now, Schenkel wrote about these wolves, and he was writing about their body language and their social structure, but he noted that these societies were not naturally formed hierarchies. They were not naturally formed wolf packs. They were basically arbitrarily thrown together individuals who were put in the same cage at the zoo because that was the wolf cage. So they all got put in there because they were all wolves. No surprise there. And he wrote as much, and he said that it was very likely that wild wolf packs did not behave in the same way as these captive wolves that he'd studied, where stronger wolves in that captive environment did tend to dominate because they were in this artificial environment. So they didn't have any other relationship except the food got brought in, they basically fought over it.
There wouldn't be a lot of hunting and stuff going on there.
Yeah, and very, very small enclosures. If you think of early 20th century zoos, they're kind of more like a series of cages. They're not like the free-roaming habitat recreations we try and do now.
So has this research ever been reproduced in the wild, or it's just it's just been based on this sort of zoo captive wolf pack?
So that kind of narrative of the hierarchical structure of the wolf society, it was kind of, people did sort of continue that research, and of course people found it a lot easier to study wolves in captivity than go out and study wolves in the wild, because wolves in the wild are, I don't know, they're like a pack of wolves, very difficult to get close to and, you know, befriend and try and actually study them with any kind of accuracy. But so, despite Schenkel's warning in his writing, the possibility that this wasn't how wolves lived in their natural habitat was ignored in favour of the better story. Basically, people liked the idea of the hierarchical structure and that the strongest survive and all of that sort of narrative to the society that he was observing. And kind of like the myth of the suicidal lemmings, it became widely accepted knowledge that this is the way wolves behaved, and we all sort of, or people just accepted that. Now in 1970, this is a long time after.
Whoa, wait! What's this about the lemmings?
Well, the lemmings, you know, the story of the lemmings, they all jump off the cliffs during their migration, which was actually engineered by Disney to make their boring nature documentary a bit more interesting. Do we know this story?
Not to mention the game Lemmings.
Well, yes, which was based on a myth as well. At least they built things to jump off, I suppose. But yeah, anyway, the popular mythology of nature is often based on misinterpreted or misunderstood or completely misrepresented versions of how it actually works. Now back to actual publications. In 1970, another major publication, I'm not going to tell you the title of it, but if you look up David Mech, M-E-C-H, he is the author of this book, which was put out in 1970. He kind of pushed a similar idea, and he's since been trying to get people to acknowledge the shortcomings of his earlier work, that he was based on captive wolves. So other work also had studied captive wolves who were often not related. As I said, they were kept in much smaller areas than they would naturally occupy in the wild, and they did tend to produce this hierarchical pattern based on the strongest to the weakest and how they interacted within those captive environments. But the terminology also slipped into the world of dog training. So it's kind of widely accepted that dogs are descended from wolves, so therefore their behavioural cues should be similar to how wolves behave. So many trainers will still teach the idea that a human dog owner must be the alpha in the house, or the dog will misbehave. There's really not any science to back up that concept. It's just something people have been repeating over and over again, and this is what dog owners are told, and this is what dog trainers train. But look, in the 50 years since David Meck published his book on wolves, he's tried to correct the science that he misunderstood or misrepresented in his book. He's published papers about how wolves behave in the wild under natural conditions rather than in captivity. So, based on his work closely studying Canadian wolves around 1999-2000, he's observed that almost always the packs were family groups. So you've got a mother wolf and a father wolf and their offspring. That's what makes up a wolf pack. So the offspring, wolf cubs grow from a little baby puppy-sized animal to a fully grown wolf in only a couple of years. They're fully grown wolves. So the pack consists of the mum and dad, this year's pups, and maybe the previous year's pups as well. So that's what the pack is nearly always made up of. So the parents, the mummy and daddy wolf, would dictate who would eat and when they would eat, and the pups who would be learning from them would basically do as they were allowed. The parents would eat first, and then they would allow the younger wolves to eat after them, and they would, give the weaker or younger wolves a fair shot at the food that they'd hunted for them. And he also observed during this period that there's very rarely, and he has never observed, a challenge to authority of the pack leaders. So there is play among the young wolves. They play with each other and they wrestle and they fight, and then they, go and do whatever it is that baby wolves do. But they never would attack the dad wolf or the mum wolf in the wolf pack. It just didn't happen. He's never observed it in all of his observations of wolf packs. So on top of that, there's been other work in Scandinavia. Wolves are all across the northern hemisphere in different parts of the world. In Scandinavia, the wolf packs showed a similar pattern. They also revealed that almost all wolf pack leaders are monogamous couples who stay together pretty much permanently. So the same male and female wolf will have a litter of pups every year. They'll have 2 years worth of pups with them most of the time, and then they will mate and breed again and have another litter of pups. So the pack itself is a constant family group of wolves, which is led by the parents of all the wolves in the pack. There is no challenging for authority. As the wolves grow up and get big enough to hunt for themselves, they leave the pack and go and find their own mates, which they mate with permanently again. The other thing is that despite the well-known understanding of wolves hunting in packs, they don't hunt in packs. The two parents hunt and bring back prey or carcasses for the young wolves to feed on. So they hunt in pairs, but they don't hunt in packs. They hunt for the pack rather than hunting in a pack. So it turns out wolf packs are just tightly knit family groups. They don't hunt as a pack. They hunt as a couple who are just trying to feed their children. In some ways, how some people might like human society to work, but certainly not the way some men would have us interpret it.
Wow, I didn't know that about wolves. I thought...
We all thought that.
Yeah.
In packs.
Yeah. Like the whole thing where they, you have they surround you. And,
yeah.
I would say that there are probably legends about that when the wolves are really hungry and there's nothing else to hunt, so they come and eat children or something. But yeah, apparently, because the baby wolves are not very good at hunting. They're stupid.
But I guess if you've got like last year's wolves cubs as well. Like, are they've got to learn the ways of the hunt somehow, right?
Yeah, they sort of
probably
sort of help
along at
as
some
they
point.
get older, but it's still like one at a time kind of thing. Yeah, interesting.
There'd also be like, I imagine, like, if the fact there is a pack, like they would be together, quite a bit of the time, or in some ways, and that humans might not encounter them as prey, but humans might encounter the pack through their own sort of hunting, whatever they're doing. And then perhaps, the pack defensive approach might be different to their offensive.
Well, exactly. If a hunter walks into the middle of a wolf pack, they're probably all going to attack the hunter.
Yeah.
Because they're also, and I didn't want to go on for too long, but they mostly stay within like 100 meters of their den until they're a certain age and stuff. So yeah, if you definitely if you came close to this year's pups, the older pups would probably attack you for sure.
Yeah.
So yeah, but then,
I tell you what though, like dogs do get around in a pack if they.
That's what I'm thinking.
If they are allowed to, I've been chased down roads by dogs in packs.
But
they're not necessarily wild dogs, but like neighborhood dogs on like when I lived in Vanuatu. They would chase my quad bike.
Oh well,
nip at my heels.
I would blame you for being on the quad bike, to be honest.
Oh, shut your fist.
And that's it for another episode of Lost in Science. Lost in Science is recorded for 3CR in Melbourne on the lands of the Wurundjeri people of the Kulin Nation, and it airs across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. You can email us at lostinsci@gmail.com, or you can find us on Facebook. We're Lost in Science on 3CR, or on Twitter where we're at Lost in Science 1. You can find us on your favourite podcast app, where if you get the chance, please give us a good rating and review, as that will raise us up in the search rankings so other people can find the science. Or you can listen to us however you listen to us now, where at the same time every week, Claire, Stu and Chris get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.